we've got these two limits out the way. Let's have a look at these final parts, okay? And we'll test how your logic is going. Because suddenly, they enter calculus, because limits, right? And then they start talking about derivatives. For a fixed value of alpha, let f of theta equal, now what is that? What is f of theta? What's its significance to the question? It's just the denominator. It's just the denominator. By the way, please note that. Can you, this is your piece of paper, just take it down. Can you draw a big arrow to that and say, that's the denominator? Because a lot of people, I think, saw it, but they didn't understand the implication that the logic had for the next parts of the question. Show that f dash theta equals 0. Show there's a stationary point when, and then they give you that. Okay, so are you ready? What would you like me to do to start off part 3? What would you like me to do? Let's just take f of theta, and let's just differentiate the thing. I'm looking for a stationary point, right? And I currently have no expression for f dash. I haven't done any calculus so far, apart from this kind of limits stuff, okay? So let's just take this function, and let's differentiate it. Now, f of theta, by definition is this, but note, please note for me, you guys are extension 1 students, you know a whole bunch of identities in your head, and you know sometimes it's smarter to manipulate something before you just launch into your calculus. Because this is a product, right? Can we think of an easier way to deal with this than to use the product rule? Yeah, this is half of double angle, right? And you didn't have to do this. You can do this by product rule just fine. But I'm going to write it as half sine 2 theta. Because that is like, that's twice as easy to differentiate, right? I don't have to worry about two functions and then combine them, blah, blah, blah. And then what have I got? Minus cos squared theta tan alpha. Now, I'm just going to remind myself, because this is an error made by HSC students very frequently, that I'm differentiating with respect to theta, which I'd better do, because if you have a look at the question, they even tell you that alpha is fixed, right? Alpha is fixed, so it can't change. So it doesn't make any sense to think about how that function is changing with respect to alpha, because alpha is not changing, okay? So therefore, to remind myself of that, what I'm going to write over here is that being that alpha is some number, that means tan alpha is also some number. Not a variable, right? It's just something that belongs in that set. Okay, I'm going to differentiate now. So f dash, what would you like me to do right? Okay, so the 2 and the half, they just cancel. Bless you. Now I notice this is cos theta all squared, right? So first thing I'm going to do is I'm going to put that constant, it's just a constant, at the front, doesn't affect my derivative. And then if you got something squared, you bring the power down, reduce the power by 1, and last step for chain rule, there's the inside derivative. Looking good? Now, this is even neater than before, because you've got cos 2 theta here, you've got 2 negatives that cancel, tan alpha is just a constant, and then you've got, oh yeah, that guy again. That's nice. Okay, so I have a derivative, right? What was I trying to show again? What am I using this for? Look carefully. Look at the question. You're trying to find a stationary point, right? Bless you. Okay. So a stationary point is defined when f dash is equal to 0, right? So I'm going to say for that value, for that to be equal to 0, I just need the right-hand side to be equal to 0, right? So for that, I need cos 2 theta plus tan alpha. Yeah? Okay, now pause, have a look at the result you are trying to prove. What would you like me to do to this line?
Divide by sine 2 theta. No, cos 2 theta.
I'm going to divide everything by cos 2 theta.
And say
Okay,
cos 2
does
theta
that make sense?
equals 0.
I suppose I should do this. Okay, I can divide through, that's all fine. That gives me the 1 that is supposed to come up in my result. It's going to give me the tan alpha, tan 2 theta that I also want, and this is still 0. So I'm pretty much there, aren't I? Yep.
We could say that the reason why we can divide it by cos 2 theta is that because this, even if you multiply it by 1 on cos 2 theta and 1 on cos 2 theta, the cos 2 theta in the denominator doesn't play any significance in determining whether it's equal to 0.
Would you write that on your paper?
I wouldn't have even.
I would probably say this would be faster, wouldn't you?
Wouldn't the fastest way be if you took out a factor of cos 2 theta and then you use the result to take.
Yeah, they're both fine. They're both fine. Yeah, they're both fine. Yeah, same result. Yeah, that's true. Okay, are you happy? I've got the result I was trying to prove. That was part 3, right? Part 3? Okay, now have a look at part 4. They actually give you this clue, right? Using part A, part 2, or otherwise. Now you did part A about 15 minutes ago, okay? So I want you to look at that and say, well, how does this relate to part A?
Oh my gosh.
10A, 10B.
Okay, so I have an A and I have a B. So, yeah.
It would be advantageous to swap the things now.
Swap what
Actually, no,
things?
it wouldn't. Never mind. I screwed up my calculations.
I have an A and a B. I have an A and a B. If I know that this is the case for some A and some B, right, I'm going to say since tan alpha tan 2 theta equals -1, there are my A and B, I know that the difference between A and B, alpha, take away 2 theta, equals pi on 2. That's the difference, right? Now have a look. They actually tell you what they want you to prove. They want theta, right? They want theta. Yeah?
Oh my god, I totally got it. Yay.
Yes. Yes. That's okay. Right. What should I do? What should I do?
You divide it by 2 because you want alpha on 2.
Okay, so I'm going to say I can do any of these things in any different order. I'm going to move this guy over here, right? And then I'm going to divide through by -2. Okay, that'll get me the signs I want. So it looks like I'm going to have alpha on 2 at the front and minus.
What?
Yeah.
I got that?
We want plus power.
You might have.
Yeah,
What have I
but
done?
Alpha's,
Where's it
going?
but
You
alpha's
moved that.
the acute angle, so it should be 2 theta minus alpha.
So these guys are in the wrong order.
Yeah,
Yeah,
that's
so
what
these
I
guys are in the wrong order. Now, just pause for a minute, because this happens, right? Did we use the result incorrect? Because look at this guy, right? See this guy?
It should be
See
the
this guy?
same.
10A, 10B. Does it matter which one's A and B?
Yeah.
Yeah.
Now, interestingly, from looking at this, it doesn't look like it matters because it's just a product, yeah?
Oh.
It's just a product. But we know things about A and B from, go back. From part A, part 2, right? Remember when I asked you about A and B, right? So A and B actually do matter, not from this result, but from that inequality we were given earlier. Does that make sense? Does that make sense? Okay, all right, so how shall I rewrite this then? How shall I rewrite this? Where do I need to go back to?
2 theta minus alpha.
Okay, very good. So you can see here the actual order, and that should make sense by the way, right? A minus B and B minus A, that order does actually matter. So this should really be 2 theta minus alpha. Does that make sense? So what should this line be? What should this line be? What am I going to get here?
2 theta.
I'm just going to add alpha to both sides. So that should really be 2 theta is pi on 2 plus alpha. Does that make sense? And then here I'm just going to divide through by 2, not -2, which gives me the sign that I wanted, alpha on 2 plus pi on 4. Okay? Now, of course, I could have told you from the beginning, oh, you need to do this order, right? But guess what students in the HSC did wrong? This, and how do you think they fixed it? When they got to this line, what do you think they did?
They just swapped it.
Oh, I would have just pretended it was right.
Yes, okay. So most people got to this point and were like, uh-oh, it's meant to be a plus. I can fix that. Look at my magic marker, okay? And guess what happened to their mark? They clearly lost it, okay? So what we had to do was go back to say, okay, something's gone wrong. Don't just pretend it's okay. Something went wrong from an initial assumption. Does that make sense?